So today we are going to solve some very nice problems based upon the free body diagrams. Okay, so we'll see what does the free body diagram mean. Before that, let's see one result which is known as Atwood's machine. So what is an Atwood's machine? Atwood's machine is a very simple machine. You have this pulley, okay, a pulley, and there are two masses. Let's call this one M1, the other one M2, and they are hanging off that pulley by means of this frictionless and weightless string. Okay, so this is ideal string, frictionless, weightless. So now, so see, what is a free body diagram? So suppose I want to draw a free body diagram of this mass M1. So I will draw this mass M1. Then I will draw all the forces acting on this mass, and I will not consider the forces due to this mass. So this kind of a diagram is known as free body diagram. So see, what are the forces acting on this mass M1? So we have one force which will be upwards, the tension in the string. The other force is it is the gravitational force. It will be acting downwards. So now suppose M2 is heavier, M2 is lighter. So the system will get accelerated like this, okay, in this direction. So this M1 will go up with some acceleration. Okay, so suppose it goes up with acceleration a, so therefore we have net force on this m1 equals to force is equal to what? The net upward force minus net downward force. Okay, so force is m1 into a, upward force is t, downwards force is m1 into g, and therefore the force is equal to what? m1 into a, which is t minus m1 into g. Similarly, this mass m2 will get accelerated downwards. So how do we find net force on it? So it will be equal to, net force will be downwards. So it is downwards force minus the upwards force. m2 into g minus t. Okay. So suppose this is our first equation. This is the second equation. That is m2 into a is equal to m2g minus t. Okay. So if we just add these two equations, what do we get? We get m1 plus m2 multiplied by a is equal to, this t and t will get cancelled. Okay, t and minus t gets cancelled. We get g multiplied by m2 minus m1. Okay, g multiplied by m2 minus m1. And we take this m1 plus m2 on other side. So we get acceleration of this system, which is m2 minus m1 divided by m2 plus m1 into g. Okay, so in this case m2 is greater, you can have m1 greater than m2. So in that case acceleration will be equal to m1 minus m2 divided by m1 plus m2 multiplied by g. Okay, is it clear, this formula? Okay, we have to memorize this formula. Okay, so acceleration of an Atwood's machine. What is Atwood's machine? You have two masses m1 and m2 hanging off a pulley which is connected to what, a frictionless and weightless string. In that case the acceleration of those masses will be equal to m2 minus m1 upon m2 plus m1 multiplied by g, if m2 is greater than m1. If m1 is greater, if m1 is greater, then acceleration will be m1 minus m2 divided by m1 plus m2 multiplied by g. Simple formula. Okay, so now, oh, Atwood's machine, I'm sorry. So let's solve some problems based upon the Atwood's machine. Okay. All right. So this is very simple. Okay. Let's read this problem. Two masses, as shown in the figure, are suspended from a massless pulley. The acceleration of the system when masses are left free is, tell me, you have this m1, m2, and m2 is greater than m1. Right. Exactly. So It's very simple. So acceleration will be 10 minus 5 divided by 10 plus 5 into g. And how much is that? This is 5 divided by 15, or we can say 1 by 3, right? So it will be g by 3. Option B. Okay. Next question. This is fairly recent, we can say. So two bodies of masses 4 kg and 6 kg are tied to ends of a massless string. The string passes over a pulley which is frictionless. Option C. Let's check. Let's check. So it is m2 minus m1, which is 6 minus 4 divided by 6 plus 4 multiplied by g. Okay, so this is 2 divided by 10, or you can say 1 by 5, right? So it is g by 5. Okay, it's option C. Good, right? So this formula is easy to apply. Okay, and this kind of question is there. First of all, get happy. Okay, you are getting 4 marks. After that, we'll see many such questions. Sorry. All right. So we'll see many such questions today. Just a second. Water got spilled on my tab. Okay. Mm. So next, now let's discuss LIP. Okay, LIP problems, we can say. Okay. So let us discuss LIP problems, and there will be similar problems. Okay. So suppose there is this man inside a lip, and mass of man is m, mass of lift is ml. Okay. Then now suppose this lift is accelerating upwards or downwards, and we want to find out the weight of this man. Okay, or tension in the lift. There will be problems like this. So first of all, let's suppose this lift is connected to, of course, some kind of a string. Okay, it is connected to a string, and now the acceleration is upwards. Okay, so how much will be the total mass? Total mass is mass of man, which is m, mass of lift is ml. Okay, that's the total mass, and therefore the net force on this lift is mass of the lift multiplied by its upwards acceleration. Okay, so mass of the lift multiplied by its upwards acceleration, which is a. That's the total force. And how much is the force upwards? It's tension in the string, or we can say rope of the lift. Okay, and what is total downward force? It is weight of this system, mass of the man, mass of the lift multiplied by acceleration due to gravity. It is acting downwards. So mass of this total force is equal to T minus mg. So how much will be T? Take that minus mg on other side. So T is equal to m multiplied by g plus a. Okay, m you can take common. It will be m multiplied by g plus a. Is it clear? Yes, no? The lift is accelerating upwards. This is the formula. Now, if the lift is accelerating downwards, then tension will be equal to m multiplied by g minus a. Okay, we can find it out similarly. See, net force on this lift is downwards. It is mass of lift plus man, that is total m, multiplied by this acceleration. And what is downward force? It's mg. Okay, net downward force will be equal to downward force minus the upward force. So it is mg minus t, right? So net downward force is mg minus t, and therefore tension will be equal to what? Take tension on this side, this ma on this side, so this will become negative on that side. Okay, so tension is equal to mg minus ma. Okay, and that is m multiplied by g minus a. So this is very simple formula. Okay, so now, okay, so let's discuss this question. Mass of a lift is 2000 kg. When the tension in the supporting cable is 28,000 Newton, then its acceleration is, tell me. Okay. You see, we have got lift, right? So we need to consider some direction of acceleration. So let's suppose it's upwards. Okay. So this is tension, and there is, suppose, man, or this lift only is there. Its mass is suppose m. So mg will be acting downwards, right? So what will be the net force, net upward force? It is m into a, which will be equal to t minus mg. Okay, so its mass is given, and then tension is given. So we can put that tension is 28,000 Newton minus mass is 2000, g is 10. Okay, so it is 2000 multiplied by acceleration. So this is equal to, we can say, this is 20,000. So this will be 8,000. Therefore, acceleration is 8,000 divided by 2000, that is 4 meter per second square. Okay, yes, no, clear or not? Okay. Now, see, we imagine that direction of acceleration is upwards, and therefore we took t minus mg. Okay, so we got positive answer. Therefore, our answer is correct. Okay, so it is 4 meters per second square upwards. If we had got negative answer, then it would be 4 meters per second square downwards, right? Okay. So in order to solve the problem, you will have to assume some direction. Okay. Anyways, so this was simple question. Let's see next one. A man weighs 80 kg. He stands on weighing scale in the lift, which is moving upwards with a uniform acceleration of 5 meters per second squared. What would be the reading on the scale? Okay. So man is inside the lift. This is the lift, and there is a weighing scale, right? Now just think about the man and that weighing scale. So that weighing scale, it exerts some force on the man. That is the normal reaction. Okay, and we have studied what is weight of a person. How do we find weight? It is due to normal reaction. Okay, so weight is equal to the normal reaction, right? So now let's check. Weight is, normal reaction is acting upwards. Okay, and acceleration is upwards, right? So I can say mass of that person multiplied by acceleration is equal to what? This normal reaction minus mg. Okay, net upward force minus mg. Okay, and therefore now you get normal reaction is equal to m multiplied by g plus a. Okay, so that is equal to m is 80, g is 10. Okay, 10 plus 5 is 15. 15 times 80. So its option is 1200, right? It is 1200 newtons. Option D. Yes, no? Okay, you said option D or C? Okay. Here, lift is accelerating upwards. Okay, lift is accelerating upwards. So you want to find out tension in the rope, or even if you want to find out the weight, it will be equal to what? M multiplied by G plus A. Okay. You want to find out weight, it is M multiplied by G plus A. You want to find out tension in the string or tension in the rope, okay, rope of the lift, then it will be total mass of the lift, and if there is somebody inside the lift, include that mass. So the total M multiplied by G plus A if it is accelerating upwards, right? So next, a lift of mass 1000 kg which is moving with acceleration of 1 meters per second square in upwards direction. Then tension developed in the string which is connected to lift is. So simple, this is T is equal to what? M multiplied by G plus A. Yeah. So this is 1000 multiplied by 10 plus 1, right? Acceleration is 1. So the answer is 11 multiplied by 1000, 11,000 you can say. Okay. Option C, right? All right. So tell me this one. A monkey is descending from the branch of a tree with constant acceleration. Monkey is descending with constant acceleration. If the braking strength of the branch is 75% of the weight of the monkey, the minimum acceleration with which monkey can slide down without breaking the branch is. So we have a vertical branch of tree, okay, and there is a monkey, okay, descending downwards. So now tell me, what can we do? Right. So there will be some tension. Okay, tension in this branch that will be equal to M into G minus A. And it's given that the maximum tension that this branch can bear is 75% of weight of the monkey. Okay. So this maximum tension is equal to what? 75 by 100 of weight of the monkey. Then how much should be the acceleration is the question. Okay. So let's put T equals to 75 by 100 multiplied by mg, and then we have mg minus ma, sorry, ma, and m gets cancelled out, right? So we have take that a on this side. So 75 by 100 is 3 by 4. Okay, so a is equal to g minus 3 by 4 g. That's 1 by 4 g, or g by 4. Okay, simple. All right, next question. A monkey of mass 20 kg is holding vertical rope. The rope will not break when mass of 25 kg is suspended from it, but will break if mass exceeds 25 kg. What is the maximum acceleration with which the monkey can climb up the rope? So what will you do? A is equal to m times g plus a, right? And m we know it's 20, and this thing is 25 multiplied by g. Okay, this is g plus a. So we can divide this. So this will be 5 by 4g is equal to g plus a. Okay. And therefore, a will be equal to what? take g on that side. So it is 5 by 4 minus 1. 5 by 4 minus 1 by, 4 by 4. That's 1 by 4, right? 1 by 4 of g, or g by 4. How much? 2.5 meters per second square. This is the answer. Option D. Okay. All right. Next question. A mass of 1 kg is suspended by a thread. It is 1 lifted up with acceleration of 4.9, lowered with acceleration of 4.9 meters per second square. The ratio of the tension is, tell me. Okay. M into g plus a, and this is m into g minus a. Okay. Gets cancelled. And how much is a? It's 4.9, means it is g by 2. Okay. So g plus g by 2 will be 3g by 2, right? And g minus g by 2 is g by 2. So this is 3g by 2 divided by g by 2. 2 will get cancelled. So it is 3, or 3 is to 1, we can say. Okay. So these kind of questions are very simple, right? And they have been repeated many times. Okay. These are all NEET questions, or AIPMT questions, we can say. Okay. So next, okay, one question. So suppose you have a monkey and the monkey is descending, not descending, monkey is moving down, okay, climbing down, we can say, with speed v. How much will be the tension? Tension will be equal to y0. So if there is acceleration, right? So if there is acceleration, some downwards acceleration, how much would be tension? M times g minus a. And now how much is acceleration? No acceleration. So acceleration will be 0. Put acceleration equals to 0. What do you get? So tension should be equal to weight of the monkey, right? Okay, so tension is not 0. Okay, so monkey is moving up, or the lift is moving up or moving down, right? Lift, monkey, they are moving up, moving down. Then tension will be equal to how much? It's equal to mg. Okay, there is person in a lift which is moving upwards with constant speed v. Then the weight of that person will be equal to how much? It is equal to just mg. Lift is moving downwards with constant speed. Again, weight of the person will be equal to mg. Okay, weight is equal to mg, right? Okay, so please remember that. So next, three blocks with masses m, 2m and 3m are connected by strings as shown in the figure. After an upward force F is applied on block m, the masses move upwards at constant speed v. What is net force on the block of mass 2m? G is acceleration due to gravity. So tell me, what should we do? It's option C. Why? Because it's moving with constant constant velocity. Right. Okay, good. After that, let's move on to the next topic, which is Hooke's law. Okay. So what is Hooke's law? Hooke's law tells us about the force in a spring. Okay, so when we stretch on the string or when we compress the string, not string, sorry, spring. So when we stretch on the spring or we compress the spring, what happens? Some force is developed. Some internal restoring force is developed in the spring which tries to restore it back. Okay, so that restoring force is directly proportional to the displacement of the spring and it's inversely proportional to the direction. Okay, direction of displacement. Oh, what did I say? I'm sorry. So let's see Hooke's law. Hooke's law is the force which is developed inside a spring. So now when you stretch on the spring or you compress the spring, what happens? There is some internal restoring force generated in the spring because of intermolecular or interatomic forces, we can say. Okay, so atoms or molecules, they want to be at the same position with respect to each other. They don't like coming close to each other than that distance, okay, the fixed distance which we call equilibrium distance, and they don't like to go away from each other, right? So because of that, if you stretch the spring, what will happen? There will be an attractive force. If you compress it, there will be a repulsive force. Okay, so force is always opposite to that of the displacement. So now suppose you stretch the spring by distance x. So this force will try to restore its length. Okay, so it acts in opposite direction and its magnitude is proportional to x. This is the Hooke's law. So restoring force, it is directly proportional to x, but its direction is opposite to x. So restoring force in a spring, which is also known as spring force, is proportional to minus x. And if you remove this proportionality sign and put an equality sign, a constant will come. That constant is known as the spring constant, different for different springs. Okay, so we need to remember this formula. It will come many times. Okay, it has started coming from this chapter and it will keep on coming. Okay, so this is the Hooke's law, right? So now, okay, so let's suppose you tie some mass, okay, tie some weight to a spring and you leave that spring suspended from this rigid support. So how much would be its displacement? Okay, so see, you are stretching it, not you, but there is some weight, okay, which is acting downwards, right? So now what will happen? So because of that weight, it will move down, okay, the spring will get stretched and they will come to equilibrium. Okay, they will come to equilibrium at some distance. So what will be that distance? If you have suppose a string, okay, and you connect some weight. So what happens? You have a string and a weight, okay. Then see what will happen. Uh, Now you suspend that weight by means of that string, okay. So at equilibrium, the tension in the string and the weight, they will be balanced. T will be equal to mg. Okay. So here at equilibrium, what will happen? The two forces will be balanced. The downward force is equal to mg. Upward force is equal to how much? It's k times x, right? It's spring force. Okay. So how much would be the extension in the spring? Suppose it is x. So that kx will be equal to mg. Okay. So you get x equal to how much? Mg divided by k. So using this formula, we measure the weights of the things using the spring balance, right? Okay. So this thing is clear. Is there any doubt? Okay. So now let's see this problem. Two blocks A and B of masses 3m and m respectively are connected by a massless and inextensible string. Okay, they should call a spring. Okay, this is a spring. The whole system is suspended by a massless spring as shown in the figure. Okay, they are saying Tm and m, it's connected by string. Okay, I'm sorry. And this whole system is connected by spring, massless spring. The magnitude of acceleration of A and B, the magnitude of acceleration of A and B immediately after the string is cut are respectively. Okay, so you cut the string, then what would be the acceleration of A and B? This is the question. So tell me, what should we do? Free body diagram. Okay. Okay. After the string gets cut. Okay. Okay. Let me tell you. So consider what condition is there before you cut that string. Okay. So you have this mass B. Its weight is acting downwards, which is mg. Okay. How much is its mass? M only. So weight is mg. Tension in the string is upwards. So tension is equal to mg. Right? It is balanced. So T is equal to mg. If you think about this one, A, mass is 3m. So how much would be the weight? So there would be some tension in the string. Okay. And then you have the spring also. Okay. So there will be some spring force which is acting upwards. So now, how much is the net downward force? The tension in the string. Okay. Plus its weight. So tension is mg and weight is 3 mg. So the net downward force is 4 mg. So from this I can find out F is equal to 4 mg, right? So now you cut the string. What will happen? Okay, B will just follow G, right? Okay, B follows what's forces? What's forces? Okay, okay. So see what happens now is when you cut the string, B will fall down. Okay, because there is only one force acting on it, that is equal to mg. So it will fall down. But what about A? So as you have cut the string, there is only weight of A acting downwards. Okay, there is no tension, right? So it is 3 mg, and now the spring was stretched because of these two weights acting on it, right? The spring was stretched by some distance. So now it will need some time to go back to its original position. Yes, no. But when you just cut that string, the spring was stretched. So the upward force was equal to how much? It was equal to F. Yes, no. Okay, because when you cut, the moment you cut the string, there is an upward force due to the spring acting on the A. Okay. So at that moment, the force is upwards only, and it is equal to how much? It is equal to how much? It's equal to 4 mg. Okay, because spring is stretched, so you need some time for that spring to go back. Okay, so upwards force is at the moment, upward force is same because the spring is stretched by the same displacement, we can say. Okay, the extension is same. So the net force is upwards. On A, the net force is upwards, and there will be some acceleration. Okay, so we can find it out. So now its mass is 3m. 3m multiplied by acceleration is equal to F minus 3mg. How much is F? It is 4mg. 4mg minus 3mg is mg. Okay, so this is 3 times ma. M gets cancelled. So acceleration is equal to g by 3. Okay, its acceleration will be upwards and it is equal to g by 3. Clear? Yes, no? So they are asking about A and B. So it will be g by 3 and g. Option A. Okay, so this was a good question. And in this kind of a question, we need to be careful, right? Careful meaning, so at the moment you cut the string, what happens? B will fall down because there is no restriction on B. Okay, there is only one force acting on B, so it will just fall down. But for A, at that moment, till that moment, the spring was stretched. Okay, spring had some extension. So just because of you cut the string, that extension will not change immediately. Okay, and therefore the force which is acting upwards because of the spring on A, it will be same. Okay, clear? Yes, no? All right. Let's see next question. So this is simple. Okay, let me drink some water. Okay. So four blocks of same mass connected by strings are pulled by force F. So these are four blocks. They are pulled by a force F on a smooth horizontal surface as shown in the figure. The tension T1, T2, T3 will be. Tell me. Let's start with one mass. Okay, the simplest one, which is okay. So first of all, we can find out the acceleration of the system. So you have four masses, 1, 2, 3, 4. Okay, and you are exerting some force. So how much will be the acceleration? Okay. So acceleration is F divided by 4m. Now consider the first mass. So there is force F acting on it. Okay, and or sorry, let's consider this mass, last one. There is tension T3 acting on it, and on this side there is nothing. So only forces T3. Okay, so I can say T3 is equal to this mass multiplied by its acceleration, right? So m into A. Okay, so which is how much is A F upon 4m? So it is equal to m into F upon 4m. So gets cancelled. It is F by 4, right? Next, let's find out T2. So to find out T2, let's consider this mass. So you have T3. Okay, for this mass, T3 is acting on this side. T2 is acting on this side. Okay, so I can say net force on it. Again, net force is on this side only. Net force is T2 minus T3. Right. So MA equals to T2 minus T3. Or you can say T2 is equal to MA plus T3. Okay, so T2 is equal to Ma plus T3. Sorry, Ma plus T3, and we found T3. It is F by 4. Okay, and this is also F by 4 because acceleration is how much? F by 4m. So this thing is F by 4. This thing is also F by 4. So this will be F by 2. Okay, so we got T3, we got T2, and what will be T1 then? So to find out T1, either we can connect this block or we can connect this block. Okay, so if we consider this one, then we have m into a is equal to f minus T1, right? Yes, no? Okay. So actually, if you want to find out T1, you can consider this one, sorry, this one, and you know T2, you know T1, using the same thing, you can find out T1 also. Okay. Or I can just say that f will be equal to T1 plus T2 plus T3. Can I say that? Yes, no? Okay. So how much will be then? How much will be the f? Oh, am I doing some mistake here? F will be equal to, no. F will be equal to, I said T1 plus T2 plus T3. No, that's wrong. Okay. I'm sorry. Let's check. Okay. Let's check whether it will be equal to, so this is M. You have T1. Okay. But T1 will be equal to T2 plus, that will be equal to T1 minus T2. So we can find out some formula. Okay, I will think about it later. But for now, let us just solve it. Okay. So let's consider this mass. So you have T2 and T1. Okay. So again, using the same thing, we can say for this mass, T1 minus T2 will be equal to Ma. Okay. So Ma equals to T1 minus T2. And then you can find out T1. Okay. Which will be equal to Ma plus T2. Okay. So T1 is equal to Ma plus T2. And that is equal to how much? So it is, I'm sorry, T2 is F by 2 and this is F by 4. So F by 4 plus F by 2. How much? 3 F by 4. Right? It is 3 F by 4. Okay. So we just wanted to find out T1, T2, T3. Okay. So it's option, which one? Okay. Option C. 3 F by 4, F by 2 and F by 4. Okay. So question is simple, right? But this kind of question is little bit lengthy, we can say. Okay. Because we have to apply the free body diagram 2-3 times. So this is little bit lengthy. Anyways, let us see next question. Two masses 10 kg and 20 kg respectively are connected by a massless spring. So these are two masses connected by a massless spring as shown in figure. A force of 200 Newton acts on 20 kg mass. At the instant shown in figure, the 10 kg mass has acceleration of 12 meter per second square. Okay, so this 10 kg mass, it will have acceleration of 12 meter per second square. The value of acceleration of 20 kg mass is, this is the question. So tell me, what should we do? 10 kg mass, then what are the forces acting on it? Let's call it. Okay, so there is only spring connected, so force in the spring, we can say. Okay, the spring force. Okay, so spring force, and now it gets accelerated in this direction. So this is simple. So no, it will be F is just ma, right? Because there is no other force, there is no friction also. So F is ma. Okay, so F is equal to, I can say m1 into a, that is 10 multiplied by how much? This acceleration. Acceleration is given 12 meter per second square. So this is 120 Newton. Now consider 20 kg mass. This is suppose m2. The spring force is equal. Okay, but now it will act in opposite direction. So it is F, and this is 200. Yeah, external F is 200, right? So we can just say that 200 minus F, yeah, is equal to its mass into acceleration. Okay, so m2 into a is equal to 200 minus F, which is equal to 120. And how much is m2? It's 20. So 20 times a is 200 minus 120 is 80. Okay, so we get a equals to 80 by 20, that is 4 meter per second square. Option A, right? This is simple.